Hey, welcome back, guys. We are going to be talking about distributed authority, a little bit deeper dive than we have in the past, back during when the Unity 6 was back in beta. So, distributed authority is a alternative to the client server model of networking that you might be used to with using netcode for game objects. We're looking at the docs here, and right off the bat, at the very top, it tells you that it's a beta feature and that it will be free until it is fully released, which I think it is now. But there is a cost to this, and we will. It is similar to how the relay service works, in that it is by user hours here. In relay, it's a little bit confusing in that they do it by concurrent users here, which in relay it's 50 concurrent users per month, which works out to be 36,000 hours per month. For distributed authority, it is 6,000 hours per month, which I think works out to an average of 8 users per month on average. So it is a little bit more expensive than relay, but distributed authority does a whole lot more for, and we'll get into what all that means in just a second. But I did want to point out that there is a cost to using this, as it is a Unity service. Okay, so what exactly does distributed authority mean in your normal client server, dedicated server architecture? What that means is that the server and the host controls the entire simulation and is the owner of the actual network session. And what that means is that when the host disconnects, or when the server disconnects for whatever reason, the entire network goes down and all clients get disconnected. What distributed authority allows for very easily is host migration. So since the authority is distributed among all of the clients, there is no central authority, so that whoever owns the session can be just moved over relatively easily. What this also means is that since clients all have authority over certain aspects of the network session, that means cheating can be a bit easier. If you're in a client host environment, whoever is the host kind of has full control over it. So if your host is a bad actor, then that just messes up everything. But for distributed authority, you might have just authority over your character and whatever you actually spawn on your client. So you kind of have to make that evaluation on your own. The other kind of limitation of distributed authority, and a plus, I guess, is that there is no central physics simulation. So you can't really do a rollback kind of netcode for your games using distributed authority, since there is no like single source of truth for your physics. Everyone is kind of handling the physics for the objects that they have authority over. There's no real way to actually like back your physics for however many ticks for an individual client. Another benefit that we get from the distributed authority is that all clients just have to push their changes up to the distributed authority service, and then they get updated states of all the network objects from the authority service rather than from another host or a dedicated server. So what this means is that in the regular relay service, client B here is trying to push up an update to the host, and client C here is waiting for that update. In your regular relay service, what happens is the client will send it up to the service, it gets pushed down to the host. That is a full round trip time for that just to get to the host. Now, when the host pushes the updates out to everybody else, that's another full round trip that it has to take for client C here to get the update that client B pushed out. In distributed authority, what happens is client B will push their change up to the service, and that's it. Everyone else gets it in that same half round trip time for everybody. So we've talked about like ownership and authority and what that actually means. What has happened in Netcode 2.0 is that we now have permissions for ownership settings on network objects. We'll go through a little bit of that once we hop into Unity. But what this means is that network objects can have permissions to be redistributed or not redistributed, if the case may be, or you can set it up as transferable. So it can, as long as the ownership is not locked, so there's a concept of ownership being locked, like if you are grabbing an object, that ownership might be locked to you, so somebody can't come and like grab it out of your hands. And then there's also a permission called request required, and this just means that one client will request ownership of an object that could then be denied by current owner. And there's a new function, set ownership lock, can lock and unlock permission settings for an object. Here. So this is kind of how distribution of network objects work. So for a single client that is connected to a distributed authority session, that client owns basically everything that spawns. Since it is the only client, this is basically like you are the host, so you control everything. When a second player joins in, the service will redistribute all of the distributable network objects evenly among both clients. So first player will have half of the objects and the second player will have half of the objects. We'll see what that looks like in a second. Use the player tools in order to see the ownership of various objects. And incidentally, this is also how the host migration will work here. So if player A leaves, even though they were the owner, then all of the objects will get moved over into player B's control. So they will own all of the distributed objects, just like this. There's also a new check here on your network objects and behaviors called has authority. So if you've used netcode for game objects in the past, you'll be familiar with like is host or is client or is server. Now since there is no central server anymore, you just have has authority. So this will return true if you have authority over this network object. And it's kind of recommended that even if you're not using distributed authority, you can still use the has authority bool in place of like is server. So even if you are just your player character on client host architecture, then has authority will still work for. Okay, finally, last little slide. With distributed authority, what would happen if player A and player B both request ownership over something that client C currently has? And if they both do it at the same time, you'll run into a race condition. So this will be something that you need to keep in mind. And I think by default, it is, if it is distributable and transferable, then the first person, whoever's packet gets there first, will have ownership of it. And there is, if request required is selected, it will return either a ownership permission failure, or I think there's some success as well, callback that you can then do what you need to do with that object. There's a little slide of like a timeline on what actually happens. Okay. And then basically to prevent those kind of race conditions from happening, you would use ownership locks. If you are swapping ownership a lot and at client discretion. So if someone owns something, you would just lock that ownership, and then you would use request required in order to request it, so people still do what they need to do. Okay, let's look at some samples. So over in the bite-sized samples, there's a couple of samples are out there that you can look at for distributed. So here in 6, so there's the Distributed Authority Social Hub. This is one that they showcased back in Unite last month. There is also an experiment, this asteroid sample here that we'll look at in a second as well. Okay, so here some of these. So in order to use Distributed Authority, you will need to have the multiplayer services package. This package will combine your relay, matchmaker, server hosting, lobby, and distributed authority all into one API that you can use for called sessions now. And when you create a session, that will create a relay or a matchmaking ticket or a server allocation. It'll create a lobby for you and then add the relay code and whatnot to that lobby that can then be searched out in a session viewer. This project does not have the widgets installed, but that makes things a lot easier too. And you can get all these from the center here. But this is using multiplayer services 1.0.2 and code for game objects 2.1.1. The Unity version I'm in is 6.0.25. Okay. So in the scenes of the asteroids package, we have this bootstrap scene, and all this is going to do is load up some different subscenes here in order to showcase some of these different demos. So there's like a parenting demo, one for ownerships. We're just going to look at the asteroids real quick because it does a pretty good job of showcasing who owns what in the actual scene. Okay. Spin. All right. This is also multiplayer play mode that we can use to spin up additional editors. Screen here, we're just going to use the live service selection, session, a name. We'll need products. Okay, once again, see the OS jobs, finding our server. Here. Okay, this is the Distributed Authority Social Hub, not experiment. Okay. So here's in the scene. We can look at ownership, and we can see that all of the objects are owned by client 1. Here, I'm going to join in as a second player, session name. And when I joined, you can see that half of our objects here owned by second player. See me here and grab, so see one of these boxes here. I grab it, it requests ownership for my player. put it down, up, and here we can see. Okay, so here, do this. Here I'm going to go back to the main menu, and all of our sessions or objects are now owned by me, the second player. So now the second player is completely in control of all of the network objects, and the game just continues on. If I were to log back in again, it should join back as player 3, actually. And there we go. So now I am joined back in as player 3. Some there, and there we go. So some other things I wanted to go through is kind of the start, and that is that install. Okay, so going to install center and the widgets. Okay, so we can open up the multiplayer center and go into quick start menu here to install quick start package. Okay, so here we have some here, and this will change having the recommendation. So if we give it, oh, I guess another thing to say is that the distributed authorities, because it uses lobbies in the background, there is a hard cap of 100 players in a given session. Stick with game objects and choose distribute now, the hosting section here. And so what this will do is this will create a scene, and it will also add in everything you need for distributed. So here we'll just add, we'll just use the Unity transport here. You can also use the distributed authority transport. Either is fine. It'll automatically switch over to the distributed authority. If you are using WebSocket, so if you want to build for WebGL, then you will have to switch this over into the distributed. Sure. Just a second. Okay. So this is what the distributed start. This is using the new Unity UI toolkit stuff for your different paths and whatnot. Okay. So here in the connection manager, it's fairly simple. Just a regular mono behavior. And what we have is using the services multiplayer here. What we are subscribing to is have a session owner promoted, and we also just have the regular on client connected callbacks. But the main thing that you just really need to know about is in the create or join session async, all we're doing here is we are switching the authentication profile and signing in anonymously. We'll also update our player name after we've signed in with whatever profile name we just picked. And then here we have our session options. For this is we give it a name and a max player, which is all you really need to start. And you have sessions dot with here. You can use dot distributed authority network. There's dot relay, and there's dot direct connection, I think. Oh, I think since it's busted. Anyways, this here will start a session with distributed authority, and that is how you connect to that service. And then you just call the multiplayer service dot instance dot create or join session, and this will first try to find a session with this name, and then if it doesn't find any, it will create its own. So that line does everything. And then in the background, the session options, what it does, like I said, it will create a lobby with the name of this session, and then it will create either a relay or distributed authority network, and then it will add the join code to that lobby, and then it will grab that join code from the lobby as for when you want to join said session. And it does all that in the background. Let's take a look here. We kind of do the same thing that we did with the social. We'll give it a name. Connect them. I believe I can spawn stuff. And what I spawn is own. That is another thing because of the distributed nature of this. Clients can all spawn their own objects and despawn their own objects as well. Okay, here we go. It says my dude joined. He gets half the objects, and so this stuff. And again, when this player disconnects, player owns everything. The player, see everything is in sync. So the spheres that each client controls, they are controlling the physics for it. So for the things that you control, those will be really smooth. For the objects you don't control, those might have a little bit of lag to them. See that as I move the screen. See, it just paused all the stuff that it doesn't control because this control is not updating. And because it was not updating, it disconnected. So see here, once we stop controlling, connected, reconnect, and everything syncs up eventually. So if you wanted to log back in with like your original colors for your client, you would need to do a little bit of extra work to link those old client IDs to like a player ID that you get from authentication. Disconnect again. So when we disconnect like normally, the switching for authority happens super quickly. So that is the, half RTT time up to the service. When it hard crashes or whatever, if you're on mobile, if your Wi-Fi drops out or you go in a subway tunnel or something, then that will take a little bit extra time for the actual connection to time out, which I think is like 30 seconds for the most of the relay services and stuff. All right, I think that is talk about. If you guys have any questions on this, leave a comment below or join us over on the Discord and be out. Yeah, I'm not sure what will be so with the holidays, but join us next time. Continue on multiplayer journeys. All right, talk to you guys later.